Greetings, guys. Another day, another dollar. We just want to make a summary of N3 signs. We want to summarize the concept, and hopefully that is going to help you guys in your exam. It surely will help you guys. So tell your friends, share this page, tell your friends that the King is live, and we do what we do. Enjoy the session and follow us on social media.
What is distance?
There we start.
Okay, let's go.
Enjoy, guys.
Okay, let's get the story going. So far, we have gone through pretty much all the 8 modules. And what I'm going to do now is that since you guys have the same textbook that we're using, the textbook being this one. This is our N3 Science textbook. It's a little bit on the blurry side. N3 Science textbook. Let's get through it and talk about what is important. First and foremost, we've got distance and displacement. That goes without saying. What is distance and what is displacement? Take note of those. And after that, you've got velocity and speed. The velocity comes after you've known what distance is or what displacement is. Distance in this case is the actual distance traveled. I moved from here to the gate. It's the distance I traveled. But displacement, on the other hand, is a shortcut. And shortcut then gives the following, which is velocity. Velocity is displacement over time. Speed is distance over time. They are both having the same unit of meters per second. And you've got average velocity on 1,3 as well. That is the sum of the first and the second divided by 2. That gives you an average. And them two definitions gives us vector and scalar. A vector is a quantity that has both magnitude and direction. And a scalar just has magnitude only. Acceleration is the rate of change of velocity. When velocity changes, when you are driving a car and you slow down, that is acceleration, or you speed up. When you slow down, it's called deceleration, not so? When you pick up the speed from 20 to 30 km to 50 km per hour, you are accelerating. Take note of that. There's a couple of exercises there. The biggest thing is to understand what is going on. I would recommend exercise 1.1, number 1, just to get your basics going with your understanding of the fundamentals. You also have exercise 11 on page 18. That is something that we can look at. And then we've got the kinetic equations or movement. The equation formulas are on 19. You've got V is U plus HE, S is UT plus half HE squared, V squared is equals to U squared plus 2AS. And all of that, the U is initial velocity, the V is final, the A is acceleration, S is displacement, T is time, and the V with the stroke on top is average velocity. All of that is on 110. We've got a couple of more examples. I would recommend 3, 4, and 5 on 1.2, just to get your fundamentals going. And then you've got a scenario where objects move on a vertical plane. When you've got objects moving at a vertical plane, you then replace your A with a G, with the gravitational acceleration. You replace your A with a G. Am I coming out even okay here? A with a G. Okay, someone is showing there. I think that's 10 gig. But that's fine. We need different angles for different classes. So, that is that. You've got a vertical plane. When there's a vertical involved, the G becomes your 9.8. And if your object is shooting upwards, it is minus 9.8. When the object is coming from the top down, it's positive 9.8. And then that flows over to force, mass, and acceleration. That's on page 14. What is a force? You gotta know that a force is a push or a pull. And mass is measured in kgs, obviously, and then A is your acceleration. To get your force is MA, 115. It's nicely written there. And then that gives birth to weight, W. What is weight and what is the relationship between mass and weight? The relationship is that mass and weight W is mg, m is mass, and the g is 9.8, the gravitational acceleration. And then we keep it moving. You can add forces, guys. Obviously, if you've got two forces that are going on the same way, you add. If you've got forces that are coming towards each other, you subtract. All of that is guided by a cardinal point. Cardinal point, I'm talking about your 4 now we shall eat. North, south, west, and east. It's coming a bit dark. Is it me or am I just out there? Much better. Okay. Cool. Additional forces we can add. And when you've got forces at an angle, if you've got two forces that are acting at an angle on a point, then you can use the parallelogram method to fix up your equation. However, with N3, I don't think we'll be wasting much time with that. That's N1 science. Then you've got issues where you've got an unbalanced force. It's on 118. They'll tell you that if a force acts on a mass m and one of the following can occur, the body does not move, or the body moves slowly, or the body accelerates. There are different conditions that influence that. They'll tell you that when the body is not moving, it means that the force is smaller than the frictional force that is required to move. If this object is just seated there and it's not sliding, it's not going anywhere, it means that Chilemechai Bugu is bigger than the frictional force required to make it slide. But if it's something like a piece of paper or a piece of toilet paper like this, if I cut this off and I put it here, chances are that this thing can fly off by short. Why is that? Because the mass is very light, nah? And it's very easy for this object to move. That's where there is a relationship between your force and your mass. The lighter the object, the smaller you're gonna need, the less you'll need of a force to push your object. You can even blow it. There it goes. But if I blow this guy, it won't move. It's basic, simple examples of science. And 3. There's a couple of examples there. 120, 121. You get an activity, and I believe that 5, 6, and 7 can be something that one can look at on page 123. And then when you've got friction taken into consideration on a horizontal plane, there's a couple of examples that we can look at. We've got 6, 7, and 8 on page 125. I'd recommend that you guys get to master those and see what actually happens, because this stuff is very exam expected. We're expecting this to happen on the final exam. And then it gets to 126. It speaks about work. What is work? Work. Okay, let's go. Velocity. And then there's linear velocity, which is v. V is WR. The W is angular velocity multiplied by the radius, right? And then you can calculate your work and power as a result of torque. The first one is the work. Work is, okay, first and foremost is torque. Torque is force times radius. We've got it all that on 138. Torque is force times radius. And then work is torque times angular displacement in radians. There's the formula. And then comes power. Power is torque times angular velocity. We're going to use these equations on a couple of examples as we go on further. But those equations are as important. Let's then look at exercise 1.7. I remember we gave each other 8 and 9. Did we do that? I don't think so. But however, let's proceed with a summary of these N3 signs. You've got momentum on page 141 that says momentum is mass times velocity, and that gives us the law of conservation of momentum. And it states that if no external forces that are acting on a system of a moving body, then the sum of the momentum will remain constant, even if the collision of the moving bodies are elastic.
Okay, guys, we are going to start a N3 example of
Let's get some friction in.
but the quality because of the internet connectivity is not good. But I hope you guys get to follow up what it is we are trying to do.
In the sketch,
So just keep
a car of mass 1000 is at
let's
rest
see what happens.
on an incline of 15 degrees with horizontal. The coefficient of friction between the surfaces is 0.1. The car is pulled upwards while the rope makes an angle of 40 degrees with the plane. Calculate A, the gravity components. mg sine of 15 and mg cos of 15. Which one is it? And second one, the force extended perpendicular to the plane. Right, let's go for it. Where do we start? Slope, car, W. What angle is this? 15 degrees. And then the perpendicular, and then the parallel. This becomes what? What angle is this? 15, same, right? So you resolve this into x and y components. This becomes W. What does this become, guys? This force, perpendicular force. W cos or W sine or W cos. Are we sure? Cos, calculate the thing and tell me the thing. This thing is 1000. Therefore, this 1000, this is mg. So this is 9800 or 98,000. So this W is 9800 cos of 15. And then W sine of 15 there. Right? That is awesome. Let's get the values of these two. So how much? 9800 cos of 15. 9800 sine of 15. How much? Speak up, guys. Yeah, cos of you guys?
9466,07.
And this one?
2536.
2536, comma?
43.
Fine. There we got our x's and our y's, our horizontal and our parallel, right? And then next stage is the F cos that's pulling the truck up. There's actually a cable that's connected that's pulling the car up. And they told us that the F there, the coefficient of friction is the car is pulled upward while the rope makes an angle of 40 with the plane. So if it's going up, then they resolve this into Fx, Fy, right? So this means that we can figure out what exactly is going on there. So what do they say we must get? The gravity components. These are the gravity components, nah? B, the force W exerted perpendicular to the plane. Yeah? Yeah, the exerted perpendicular to the plane. Which one is it? Yeah, perpendicular, I see. Yeah, cos. See? Yeah. And then frictional force F mu is how much? They gave us the 0,1. What does that 0,1 do? The coefficient of friction. So how do we get the frictional force F mu? Because you can see there's that formula that says mu is F mu over W. Yeah, so what is what? What is my F mu? We've got the given value, coefficient of friction of 0.1. H is 0.1. Okay, and then this one is which one? Yeah. Roshmi sa formula verimi. Is it like that? And then we get the F mu. And then W is what?
Weight.
Which one? 9,800. Or the weight of the object, né? Okay, and then mu multiplied by 0,1.
Yeah.
F mu over 9,800. And then this goes there, it becomes what, 980. Okay, so if that is the case, the F mu is the one that is pulling up. Like the F mu DLT, it's going up, right? If it's going up, what is the formula for up?
Hi guys, the stream is not so good. We'll do this again, but the quality and the voice and everything is not balancing out. But we'll try to stream this in a better network area because so far it's not doing so great. No.